talk about what we learned yesterday. So yesterday we were multiplying a monomial, right, by a binomial or by a polynomial, which means more than one. So I'm going to use my black ink, 2x, so we set it up out here. My monomial goes out here. My binomial is up here because I've got a 1 by 2 box. Remember that? So 2x times x cubed, Dylan, is 2x to the what power? To the 4th power. Excellent. I have 2x times negative 3x squared. How about Mario? Mario, what is 2x times negative 3x squared?
Negative 6x.
You guys are on it. Okay, questions on that? That's what we did yesterday. Perfect. Okay, so yesterday's last thought was, using what we've learned today, can you predict how we will multiply polynomials tomorrow? Could we still use the box? Not a 1 by 2 box with this one, right? Who said 2 by 2? Okay, Kaden. Why a 2 by 2?
Because on one side you put the x plus 4 and then
Perfect. So let's look at that. I will be able to multiply binomials and polynomials using an area model. That's what we're going to do today. I will be able to describe the necessary dimensions for my area model. All right, so no notes yet, okay? I just want to explain to you how we're going to do this. So how many of you have seen foiling? The FOIL method. Just like this, where it's a double distribution, where you multiply x times x, x times 2. I want to see the hands raised high. I want to see how many people know how to FOIL. Excellent. How many people, hands down, how many people have used the area model before? The box method. Okay, a lot of you. Perfect. Okay, we are going to solely use the box method today for your homework. All right? And the reason is, and I'll show you right now. So I'm going to go ahead and FOIL these two binomials. So I've got, follow my, thank you so much. Follow my arrows. I've got an x times an x, which is x squared. I've got an x times a 2, which is 2x. Change my color here. Then I have a 4 times x, which is 4x, and I have a 4 times 2, which is 8, which is neat and nice. It gets a little bit more difficult when you've got a binomial times a polynomial, or when you got coefficients. It gets kind of messy. I really like the area model because I would much rather see exactly what I need to fill in. That way I don't forget anything. Sometimes you can forget things in here. Correct? I'm going nice and slow, but sometimes you can forget. So x times x is x squared. X times is just like multiplication table, right? X times 4 is 4x. 2 times x is, and 2 times 4 is 8. All right, everything's filled in. I know everything, that I've got everything that I need. So I'm going to go ahead and combine like terms now. I've got an x squared. Do I have any more x squareds that I can combine? No, so I'm just going to write down x squared. I've got a 2x. We're done with that one. I'm going to cross it off. Done with that. I've got a 2x and a 4x. I can combine those to make 6x and a positive 8. Over here, it's kind of like a diagonal. I've got an x squared. That one's all by itself. I've got a 2x and a 4x. Makes a total of 6 x's, and then I've got an 8 by itself here. Okay, questions so far? All right, so the next one, I'm going to do a nice clean model for you. X times 2x is 2x squared. X times 1 is x. 1 times 2x is 2x. 1 times 1 is positive 1. I know I have to, I've got 2x squared. That one's all by itself. Then I have a 2x and a positive x makes 3x. Didn't change my color. And +1. Here's my steps. Set up your box to match the dimensions of your factors. I already had a box set up. It was a 2 by 2 box. Multiply terms to fill in each box. That's what we did. Combine like terms, and it's on a diagonal. Question. All right, copy that down. Okay, so let's continue on to the next one. I don't think I need to do pencils down on this one with this class. Let's get whiteboards out. In fact, not whiteboards, but just make sure that you've got, get those burritos out, and let's do it. Let's use our desk. Okay, how about, let's do Maria. Maria, can you fill this in for me, please? Okay, thank you. And 1. Okay, Johnny, can you combine like terms for me? Tell me what you write. 6x squared, perfect. Plus 5x. Perfect. We combine these two right here. Yes, Philip? Yes, these two will always combine diagonally in an area model. That's not true. If you were to do an area model where this was, we'll get to it in a little bit. I don't want to complicate it. Let me say it this way, Philip. You need to check. Usually, 9 times out of 10, a diagonal is going to combine their like terms, unless you've got different exponents here of different sizes. Then sometimes they will be side by side, but they've got different exponents. You got to watch it when you're questioning whether it's a 2 by 2 or a 2 by 3 and you've got different exponents. When you're questioning it, then you should definitely be looking inside of it and questioning it. But this, you have to question that. It just kind of comes natural, right? All right, good question. All right, let's move on. Try this one together on your desk. Okay, so unfortunately this is the same problem, so let's move on to, oh, perfect. Let's move on to Sage and Scribe. So let's have, okay, I'm going to ask you a question, guys. Did you like it better when you work at the same time and discuss later? Yeah. Okay, work at the same time and discuss later. Record. You guys did really, really well on that. I'm pleased. Okay, so Eduardo has volunteered to do the first one. Which one did you do, Eduardo? On the left or on the right? On the left. Okay. So why don't you Sage for me on this one?
All right. So then you do 6x minus 5x, and then you do 3x squared.
Perfect.
And then 5x and 5x,
Good.
and then you do 25x.
Perfect. Excellent. Are you ready to combine like terms for me as well? Awesome. What am I going to combine? Perfect. All right, you guys agree? Thumbs up? Yeah? Fantastic. All right, let's see. Popcorn. Eduardo, pick somebody. Awesome. All right, Andrew. (56x squared). Perfect. Negative 64x. 49x. Excellent. Negative 56. All right, what am I going to combine? Fantastic. And what are my totals? Minus 56. Everybody agree with that? 56x squared minus 15x minus 56? Thumbs up? Yeah? All right. Awesome. Good job, guys. All right. Here's a showdown. Okay? A little bit different. Be careful. All right, now Showdown should normally be on whiteboard. All right, so grab the whiteboard. Why don't you work as a team, and then when I say Showdown, you're going to turn... Okay, I'll give you instruction in 1 second. Okay, so one whiteboard for 2 people, or do you all have whiteboards? Oh, then do your own. Do your own, cover it up, and then when I say Showdown, you're going to turn around and show everybody else your 4 pod groups, right? And see if you got the right answer. Well, obviously you can't use that one, right? So go get another one, or clean it off. All right, go ahead, go. 1. Okay, Showdown. Compare. So you've got 4 examples right now. If somebody's wrong, you got to figure out who's wrong and help them figure out what they did wrong. Perfect. That's what I want to see. All right, that's better. 5, 4, 3, 2, 1. So how'd that go?
Fantastic.
Okay, Mario is having some, they're having a confrontation right here. You agree? Okay, Mario's going to help me. All right, Mario. He's confident. All right, so tell me what goes in the first box.
X to the 4th.
X to the 4th power. Excellent. And the second box?
3x squared.
3x squared.
Negative 5x
Negative
squared.
5x squared. Negative 15. Perfect. So now all you have to do is combine like terms, right? What am I going to combine?
We're going to combine the negative 5x squared with the 3x squared.
Perfect.
And then we have the 4th power
Hey guys, it's Mario's turn. Right? Okay, go ahead.
minus 2x squared.
Did you catch your mistake, or were you right and they were wrong? You were right and they were wrong? Yeah? I like how confident you are. Good job. Excellent. Okay, let's move on.
Wait, that was right?
That was right. Yeah.
Why was it be 2x?
2x to the 4th? Because at this point we're combining like terms. We're saying I've got negative 5x squared, like those big x squared boxes, and 3x squared boxes makes a total of negative 2x squared boxes.
Like,
This one? No, x squared times x squared equals x to the 4th. Because that means x times x, and that means x times x. So x squared times x squared is x to the 4th. You guys got it? Good, fantastic. I would have never even known that you guys didn't get it unless you guys were arguing about it, right? Fantastic. Okay. I don't think we need team play. I would rather you guys get started on your homework.
Yeah. You know what? Yeah, it's homework. Yeah, homework.
Uh-oh. Okay, never mind. Let's do this one. Oh, come on.
What's the challenge?
What's the challenge? There's a challenge. Okay, too much noise. 5, 4, 3, 2, 1. Take the challenge. Here is your binomial times a polynomial. Set yourself up a box with the appropriate dimensions and simplify that. All right, how about Joseph? Joseph, can you explain to me what type of dimensions I need to use for this? Excellent. Ooh, which way should we do it? A 2 by 3 or a 3 by 2? You did a 2 by 3? Okay. Could I do a 3 by 2?
No.
Yes, you could do a 3 by 2. All right. So, all done? Thank you. I can't. Give me 1 second. Okay, so let's continue. So this is going to be a 2 by 3. All right, Joseph, that's okay, right? All right, so what should I write over here?
X and then negative
Perfect. X and negative 2. Everybody be respectful. Thank you.
X squared, negative 4x, 4.
You want to pass the torch or you want to finish it? Okay.
X to the third,
Perfect.
negative 4x, negative 4x squared,
Perfect.
4x, and then negative 2x squared, 8x, and negative 8.
Well done. All right, what are we going to combine?
Well, you can drop down x cubed, right?
Perfect.
That combines negative 2x with negative 4x squared,
Good, which makes a total of
negative 6x squared.
negative 6x squared. And then,
That combines 8x and 4x.
Philip, you seeing how these are also working out? Okay, go ahead.
We've got 12x.
Fantastic. And
With broad negative x.
what's the matter? I'm hearing questions. No? Not on this? Simple?
Subway.
Subway.
Not so good, huh?
It does sound good, but let's get back on math. All right, 5, 4, 3, 2, 1. Any questions on this? You guys confident that you can set these up? Let's do a geometrical one then.
Oh, I love you.
All right, do your best to set it up. I'm going to give you 1 minute to set this up, and then we're going to start it. Let's remind ourselves of the area of a triangle. Raise your hand if you can tell me the area of a triangle. Okay, Brenda, louder. Hey, you guys, if you forget the area of a triangle, you can just look at it as, okay, that was a fail. This triangle right here, that side would fill in that right there, right? And that triangle right there would fill in that. So isn't this just, and how do I find the area of a regular rectangle? Base times height, or I should have that opposite. Base times height, and I'm just cutting it in half. That's why there's a half in front of it. You find the base times height, and then you cut it in half. So just concentrate on the base times height first, then concentrate on cutting it in half. Go. And, okay, how about Gilbert? Gilbert, how did you set this up?
I put 3x and negative 1 on.
Okay.
And 2x and j on.
Awesome. So where do I go from here?
I got 6x squared,
6x squared, 9x, negative 2x, negative 3. So what's my total here?
6x squared plus 7x minus 6.
All right. So that is base times height. So what I did, what you did, sorry, excuse me, Gilbert, I'm taking the credit for that. Area equals 1/2. I found the base times the height. The base is 2x plus 3, and the height is 3x minus 1. So what Gilbert did was he set that up using an area model. So what's the last thing we need to do, Gilbert? I've got base times height. What's the only thing you haven't done? I found the area of the entire square. Exactly. I found the entire area of the square. That's what this is right here. The area of the square. How do I go from a square to a triangle? Split it in half. Exactly. So in order to split it in half, I'm going to take half of each one of these terms. So what's half of 6x squared? 3x squared.
Oh, you did it
Uh-huh. What's half of 7x? You could write it 2 different ways. You could put 3.5x, or you could write it just 7/2 x, right? 7 divided by 2. And what's half of -3? Or -3/2? Question? All right, fantastic. You guys, I need the talking, the side chatter to stop for a second because we're on the screen. Freeze! Everybody freeze. What did you learn today? Alex, what did you learn today?
The box method.
The box method. Okay, how about Johnny? Specifically, what were we multiplying? Not monomials today. What were we? Binomials times polynomials, right? Some of them were binomials times binomials. Some of them were binomials times polynomials. Andrew Partita. The final step when multiplying polynomials is to combine what? The final step when multiplying polynomials is to combine what do we combine? You got this. You know this. You know this vocabulary. Combine what? Blank terms. Combine. No? Jacob, want to help him? The final step when multiplying polynomials is to combine. What's that last thing we do when we have? Perfect. Combine. Whoa. I didn't hear, Andrew. Did you say that? Oh, I apologize. I did not hear it. Well, I know, but I was asking Andrew, and I didn't hear like terms. Okay, on your assignment sheet, I would need an area model of blank times blank to simplify the following. What do you think, Christian? Yeah. What do you think you'd need? What type of area model do you think you would need to simplify this trinomial times a trinomial? A 3 by 3. Excellent. Okay, don't put anything away. All right, we're going to go over homework answers. Since I have you before lunch, if anybody puts anything away, I'll just keep you after the bell rings. Okay? All right, good job today, guys. Here's your homework answers.